A little bit disclaimer. This may not be true for everybody. This is my attempt to make connections between mathematical concepts and the real life. If it's okay, please hear me out as I make it real mathematically. Episode 1, Mindset. What do you usually do when you experience defeat, failures, when you feel setbacks? In reality, there are many ways to manage such defeat. Some people tend to run from it. Some people tend to sulk and stay on it. Some people go out with their lives unaffected by it. And some, or a few people, tend to rise from it and push forward, move further with their lives. If it's okay, let me share a math secret behind what is best to do in these situations. Let me explain a better mindset mathematically using the slope of a line. The slope of a line tells the direction of the graph. It also tells us what type of tilt it would have. Mathematically, it is denoted by m. The most famous formula used to denote it is the amount of change in y coordinate divided by the amount of change in x coordinate. This is also known as the amount of rise in y divided by the amount of run in x. Let us consider this formula as we relate it to our real life. As we make it real, let us consider the following situations. Let slope be the chance for success. Let the change in y be the rising from defeat. Let change in x be the running from defeat. And let us take into consideration the left to right movement in our graph be also the movement in time. As I try to make this mathematical concept be related to real life, we could actually have these following situations. Situation number 1. If the amount of change in y is bigger than the amount of change in x, the value of the slope is different than otherwise. Consider these two situations and let us have these graphical representations of the relationships later. Let's start with our figure number 1. In this figure, the amount of change in y is 2 while the amount of change in x is 1. Let us consider this point in this Cartesian plane. The amount of change in y corresponds to the amount of rising, 2, while the amount of change in x is the running, 1. Therefore, we have this next point. Repeating the process, we will also get this another point. Let us use these 3 points and connect them to find out our line. Our graph will look like this, and this graph has a slope equal to 2. The result when we divide 2 by 1. In figure number 2, let us say that the amount of change in y is equal to 1, while the amount of change in x is 2. Considering the same point of reference, when we apply the amount of rising and running, 1 by the amount of change in y, while 2 to the amount of change in x, we could have these 2 additional points for figure number 2. Then, if we are to connect these 3 points, we would see this line. The slope for this line is computed to be 1 divided by 2 or 1/2. The line on figure number 1 has a better tilt and a higher disposition. The difference was actually brought by the fact that in figure number 1, the amount of change in y or the amount of rising is bigger than the amount of running or the change in x. The more you rise, the bigger the slope. In short, when we experience defeats, let us try to rise more than run. Situation number 2. Given the same amount of change in y, but in one, the amount of change of x is positive, while for the other is negative, the value of the slope differs from one another. Consider these two figures where the amount of change in y is the same, and it's equal to 2. If in figure 3, the amount of change in x is equal to 1, we will have this graph. Consider this reference point. When we apply the amount of change in y in a rising and the amount of change in x in a running, we will get this point. Repeating the process, we will have this second point. Using these 3 points and connecting them, we could create the graph of a line. In this figure, the slope is computed as 2. In figure 4, the amount of change in x is negative 1, the opposite of the value in figure 3. When we use the same reference point, we could plot this next point. Notice that the amount of change in x or the running was reversed because the value is a negative number. Repeating the process, the next point is located differently. We can connect these 3 points in this manner. But since we are moving from left to right, the line can be drawn like this. Here, the slope is computed as negative 2. Notice the difference between the two graphs. When the amount of change in x is a positive number, the graph tends to move upwards, from left to right. However, when the amount of change in x is a negative number, we can observe that the graph, as we move from left to right, seems like it goes downward. Aside from that, notice the difference between the two slopes. In figure 3, the slope is computed as positive 2, while in figure 4, the slope is computed as negative 2. The value of the amount of change in x tells us the tilt or the direction of the graph and the sign of the slope. If the amount of change in x is positive and the running is towards the right, the slope is positive. We can say that when we experience defeat, and if we choose to run, let's just run forward to the future situations. By doing so, there is still a chance for a better success as we are moving upward. Doing otherwise, if we choose to move backward, let's say going to the past, we will create a situation where we lose a better sight of tomorrow and we're just going to continue downwards. Situation number 3. Here, let's consider that the amount of change in y is 0. For this figure, let us use the given situation and add the amount of change in x, which is a positive constant, 2. Given this reference point or starting point, we could no longer rise up since the amount of change in y is 0. What we could only do is to use the amount of change in x, or the running, by 2 steps. Hence, we have these 3 points. If we are going to connect these 3 points, noticeably, we will form a horizontal line. Using the formula for the slope, we could compute here its value to be 0. Notice that there is no tilt with the line. This is actually given by the situation that we are not anymore rising because the amount of change in y, or considered to be the rising, is 0. Without any value for the amount of change in y, our slope is still real, however, it is 0. If we continue with our lives moving forward without even trying to address the resiliency in the defeat, we will not be creating a better chance for success. This would mean that we really need to acknowledge the defeat by rising from it, even just by a small amount. Situation number 4. Here, what if the amount of change in x is 0? For this given figure, let us try to denote that the amount of change in y be any constant, say 2, well then again, the amount of change in x be equal to 0. If this is the case, with this point here, we are just going to move up 2 points, but we will no longer run to either sides. This is because the amount of change in x is 0. Connecting the 3 points, we could create a vertical line. Notice that the line just keeps on increasing upwards. However, if we are going to use the formula for the slope, being the amount of rise over the amount of run, we could get a value for the slope that is non-existent. Because when we divide any positive constant by 0, it will become imaginary. If there is no amount of change in x, or running to either side, the slope is not real. What does this tell us? I am sharing this situation to express that if we experience any defeat, it is never wrong if you choose running. Well, running is still part of the solution. Running is still an integral part for the slope of a line to be real. Running, or the change of x, makes the slope possible. So if ever you run after defeat, it's not a minus points to you. Do not think less of you. You can still consider running. With this, the slope is still real and the chance for success is still possible. Just take into consideration that if you decide to run, run forward. On to our last situation, situation number 5. Let us consider this figure where both amount of change in y and the amount of change in x be real numbers. If we are going to plot the points using these considerations, we will have this graph. We are going to rise twice and then run towards the right twice. Repeating the process, we'll have these 3 points. If we are going to connect these 3 points, we will have this figure. However, observe that this is not a figure of a line. This is
a figure of a line segment. Hence, to make it a figure of a line, we need to extend this figure into both sides. Doing that, we are going to make arrowheads on both sides. These two arrowheads tells us that the line extends infinitely on both sides. Highlighting this single arrowhead, this tells us that from left to right, it extends infinitely and it does not stop at these three given points.
Take note that as we continue in our journey of our lives, we always face these challenges to either run or to rise, to either run forwards or run backwards, to run but not to rise but not to run. We also need to notice that we should not settle with what is our decision today. We need to continue striving, fighting, praying, hoping, envisioning for a better chance for success. Let the slope magnify an arrowhead in our line.
These are the 3 tips that we could consider when connecting the slope of a line to a real life. They are now yours to take. May one of these, if not all, help you.
This is why I do hope that our mindset be guided by the slope of a line. This is me making it real mathematically. If you want more math concepts be made real, see you in the next videos.